It hurts to say, but it's already been 6 entire months since we blew the engine up in the Ferrari, but if I'm being honest with myself, I probably knew it was going to take this long or longer to get this car back together and out on track, but we've been talking with 4Piston Racing, and we know our engine is assembled and it should be shipping our way soon. So I want to dive back into this thing and start making progress so that we are ready when that engine shows up so we can minimize downtime. There's a lot of work to do and a lot of cleanup involved, so let's get to it.
Because it's been so long, let's rewind and pick up where we left off. If you missed it, the last time we had a 308 episode was almost 6 months ago, back when GTA finals were taking place. We had the car out on track in competition, and it was improving with each successive lap. We expected that trend to continue, but the gods of speed had different plans for us, and we blew the engine in bus stop on day 2. And that was a heartbreaker, but we got the car back to the shop and did the only thing we could do, and tore it apart so we could get the engine sent back to our friends at 4Piston Racing so we can figure out what went wrong and we can get a new engine installed in its place. But that brings us to today. The car has been sitting for 6 months, which is admittedly longer than I had hoped. But getting a new engine built and making some of the changes that we need has taken more time than expected, so between our last off-track excursion and the amount of time it's been sitting around, it has collected some serious dust. And I think getting this thing cleaned up both inside and out is the first thing on our list. I don't want to dive back into a build with a filthy car. Now, as we get this thing cleaned up, I know the number one question in the comments is going to be, Mike, what is the status of the engine and do you know what happened to it? Why did it blow up? And the unfortunate answer is, we're not entirely sure. As you guys saw, we threw a rod at the track and that rod is blue, and the data suggests that we lost some oil pressure before the thing blew up. That would tell us that we spun a bearing. But once 4Piston got a hold of the engine and looked inside of it, they found that there was another rod that was bent, and they have a theory that we may have somehow blown the head gasket and hydrolocked the engine, contributing to its failure. Whatever the case may be, it's a freak accident of racing, and it sucks that it happened, but it's just a real part of what we're here to do. But now that the car's cleaned up, I think it's finally time we start crossing things off the list and make real progress towards having this thing ready for when that new K20 shows up here shortly. The first thing on the list that I want to tackle is a quality of life improvement. It's not consequential, but it matters to me. Some of you may remember that we mounted the control pad for our Haltech Nexus R5 ECU up on the top of the roll cage. I like this position because it's easily reachable, but what I didn't fully consider is that it's hard to see while I'm driving, and this control pad does give visual feedback about what's going on with the systems of the car. Once I've got a helmet and a Hans device on, it's hard to take my eyes off of the track to look at the pad, so let's move it. My thought is to relocate the pad to the same mount that holds my aim solo. It's right in my line of sight, it's reachable by hand even when I'm strapped in, and this should be doable with just a simple bracket. So I hopped onto Fusion 360 and drew one up, and what we're going to do is 3D print this so we know that it fits before we send it over to SendCutSend to be made out of aluminum. I'm still using my Bamboo Labs X1 Carbon 3D printer, and so far I love it. This thing works perfectly every time, and I still haven't had to fiddle with it. So if you're looking for one, my personal suggestion, this thing has been awesome. The only thing it seemingly can't do is account for when you mess up your own 3D model, and forget to account for some features on the backside of your mounting plate. In my case, these raised bumps, which are interfering with our bracket sitting flat against the original aim solo mounting plate. So, after a quick modification, I reprinted it one more time, and this thing is so fast that it only took about 20 minutes to pull off. I slightly undersized our mounting holes and added some wall layers so that I could thread the hardware directly through the 3D printed part, and then I doubled it down with some lock nuts just for safekeeping. Because I was concerned about space, my bracket design for the original keypad location isn't the best, and getting to the hardware / getting it undone isn't the easiest, so I'll be glad to avoid that in the future. The new location will be very easy to service should we ever need to remove this thing for any reason. On the other hand, I'll feel less like a fighter jet pilot as I start my car, but we all make sacrifices in the name of speed. Now, I will be curious to see how flexible the final aluminum bracket will be in this position. The 3D print moves quite a bit, but I have a feeling rigid aluminum with a bend in the middle should be plenty strong. But I don't want to go to press a button and have the whole thing push away, so I might need to add a secondary support to the ram mount itself so nothing can move. As a proof of concept though, I like this, I can reach it, I feel good about it, and I think this was something I probably should have done quite a while ago. With the creature comfort crossed off the list, let's turn our attention to the motor.
Now obviously we don't have our engine yet, and we're going to talk about that later in the episode, but I still want to be prepared for when that engine shows up, and this is the water plate and alternator mount that was on the K-Series previously. And this unit from K-Tuned worked really well. I don't have any complaints about it, but I had to modify it to work with our application because we converted to dry sump and the pump was in the way, and it failed, which we knew was going to happen as well. This was a ticking time bomb, but it was a stopgap. I knew that someday we'd have to re-engineer this, and that was what I was going to do first in this episode until I realized Rob over at TrackTough came up with a solution for us. So let's take this one apart. I'm going to show you guys why it failed, and then I'm going to show you how we're going to fix it. So as said, this is our alternator mount, and the way that I have this configured is completely set up upside down. I took these brackets here and flipped them 180 degrees in order to clear the dry sump pump that sits below them. Originally, this would be completely rearranged. These parts come down here. You can even see these bolt holes are supposed to be down here. None of that's that way. Now, in order to make this work, we bolted it in higher up, so we offset it here, and then we welded across the top. But we kind of knew that that weld was going to be weak. There's a lot of tension trying to pull on this from the belt, and that eventually that was going to break. And it did, and surprisingly, it didn't cause an actual failure. The alternator was still working despite this crack being here. So kudos to the rest of the part, it's still well built. But this isn't a permanent solution, so what are we gonna do about it? Well, I don't wanna bore you guys with boring details, but I'm also really into the nerdiness of fixing problems once we go racing, so we're gonna come up with a solution. And initially, I was gonna sit down and draw this entire thing in CAD and remake it with Send Cut Send. If we look at it, all the parts and pieces are just flat material, and conceivably, this would be possible to design and engineer, utilize them to cut it all, and then do a little bit of machining to make it work. But a few months ago, I called up Rob at TrackTough and I asked him if his water plate worked with the daily engineering system, and he said it doesn't, but I've had a few guys ask, maybe I can come up with a solution, and he has re-engineered part of it to work. This is a bolt-on solution to our problem, so I'm gonna save ourselves a ton of work and not re-engineer all of this when we can just buy this off the shelf. And that's what I did. I bought this. I wanna support Rob. He's a small business. He makes awesome parts for race cars. This is some cool stuff. If you don't know what this is a water plate. As you can tell, these are largely the same, slightly different, but largely the same. And the purpose is to eliminate the factory water pump, the mechanical water pump, because it's probably not up to the task of pumping water all the way to the front of our car, when in reality, these cars only pump water about a foot until it gets to the radiator instead of 16 each direction. So this allows us to get rid of the factory water pump. We can put AN fittings on it and hook up to our electric water pump and alleviate all of our cooling system problems. This kit worked really well. To be clear, the K-Tuned parts, plenty nice, no complaints about them. It was up to the task. It just was weird for our configuration, and I don't really want to try to scab something together when Rob makes something that's bolt-on. So let's put this one together with our alternator and see how it works.
One variable I am curious about though is to see how crafty we may or may not have to get with the AN fitting that comes out of this water plate. It looks like clearance to the alternator might be tight, although the adjuster is currently turned all the way in and we will only gain clearance from here. Ultimately, I know Rob designs these parts well, so I have confidence that it's going to work just fine.
All right, and here's our finished unit. One last comparison. As you can see, this is a much daintier unit than this one is, but this one's totally rearranged and again, just not the right tool for the job. Rob's done a very simple job of making this one relatively universal. We could run an S2000 alternator with it. We can run a K-Series alternator, all sorts of stuff. We can run different size belts. It's got a lot of adjustability in the bell crank at the top. Overall, I think this should work. Rob, we're gonna find out if it fits, I'll tell you that. But otherwise, I'm excited. We can bolt this onto our K20 once it arrives. Another cool part, all these parts are K20 and K24 interchangeable, and we can cross this one off the list.
I'd like to imagine that our next engine won't be coming in and out of the car nearly as often as the first one. But in the event that it does happen, I want to make that whole process a lot less of a headache. As it stands, removing the engine requires removing every single AN line from the engine bay, which is tricky and requires a lot of tools to do, not to mention the fact that it makes a huge mess.
And that's why I want to use some of these. This is called a dry brake fitting, and you've probably seen them before in our old episodes for our brake lines. We used much smaller versions of this. But now Vibrant Performance makes some big ones, and we can use them on the rest of our fluid hoses. If you don't know what this is or how it works, in short, it allows us to remove any components we want to without needing tools and without spilling any fluid or introducing air to any systems. If you can imagine this in the middle of a fluid line, let's say our oil supply line coming from our dry sump tank to the engine itself, if we just unhook that line, we'd take all of the oil and dump it out of the tank and make a huge mess. But with this here, we simply press the halves together and we can pull the line apart and the ends are closed. No fluid will come out and no air will get in. We can then remove whatever components we need to without making a mess, without having to drain everything. And then when we're ready to put it back together, we just line the pins back up, press it together, and now it has full flow characteristics once again. This one being a Dash 12, it will flow everything that a Dash 12 needs to and won't impede anything, but it makes service a lot easier. And this is stupid, but I've decided I want a steering wheel hook inside of the car. Every time I get out of the thing, I've got to put the steering wheel somewhere, and then it's hard to grab once I'm outside of the car. I need to move the car. Very much first world problems, but it needs a solution. I was gonna 3D print a hook and just make something simple, and then I realized I can get a nice billet one, so I did that. But I'm an idiot, and I bought one that's 1 3/4 inch diameter because I'm so used to that for normal roll cage tubing, and then I realized we put 1.5 in the Ferrari. So I have 3D printed a solution and made what is essentially some rod bearings to press into place and drop the diameter. And let's see if they fit. I'd say that works pretty well. Needs a little bit of adjustment. Yeah. And now we've got a 1.5 inch adapter. We'll clamp it into place, and now I don't have to think about where to put the steering wheel anymore.
And I'm going to admit this probably sounds like a very silly issue to solve, but every time I get out of the car, it becomes a question of where do I set the wheel? Does it go on the floor or against the shifter? And then when I need to move the car after the fact, it becomes an ordeal to find the wheel and then lean in and grab it. It's frankly annoying, and I'd rather have a permanent place for the wheel to live so I don't have to think about it ever again. And now the wheel is in reach whether I'm in the car or reaching in from either side. And is this silly? Yeah, but I'm happy that I made the change.
So for the last project that I want to start in this episode, and this is going to be probably the biggest thing left to do to this car, period. I don't know how soon we'll get it done. This is going to be a big one. I want to move the location of the front coilovers. And we talked about this in some of the previous episodes. If we look back at how the car was acting on track, we've got some spring and damper issues to sort out. And one of those issues that we're dealing with is that the motion ratio of this suspension isn't quite ideal. We have to have a really stiff spring on the car in order to have an accurate amount of wheel rate. And that's not really what we want it to have. The damper's having to work way too hard in order to actually control the spring, and as a result, we have some suspension issues. So what I want to do is move the coilover from where it normally is, outside, kind of just behind the wheel, and I want to go inboard. We're going to make a push rod setup. So given that the coilovers are located on the car right now, we're just going to use this as our mock-up coilover. Use your imagination here. What I want to do is I want to relocate these under the hood, which there's not a ton of room to play with, but what I'm imagining is something right around here. We'll mount them at the base in the center of the car, and then up here we'll have a bell crank, and the bell crank is what's going to make this whole thing work. We can give the bell crank a leverage ratio or a motion ratio, basically one side of it longer than the other, that can allow us to run a much softer spring on the car while maintaining a stiff spring rate, a wheel rate in this case. So I want to 3D scan this whole thing and then start drawing it up in CAD and get at least a proof of concept, maybe 3D print some parts and kind of set them in here and make sure it's all going to work. And then we're going to have to do the math and all the figuring. We'll have to see if we can reuse our current dampers, or we'll have to have H&R make some new ones. But as a whole, this should work. And I think it will make the car drive a lot better, and it'll get rid of some unsprung weight too. So that's what we're going to do.
And finally, we have an excuse to use our 3D scanner once again. So in order to do that, we're going to put some reference markers all over the engine bay so it knows where it's located in 3D space. On the other hand, I'm frankly hoping that the rest of the front bay is dirty enough that the 3D scanner will pick it up without the use of any sort of spray to dull reflections. The scan job that I'm going for is admittedly quick and dirty. I don't need all of the information here. We're not going to create a perfectly accurate model of everything under the hood. I just need some reference points, something that I can then use to draw this stuff up in CAD and know that it's accurate enough for me to design parts in Fusion 360 that can be used in real life.
But I know some of you guys are already saying, Mike, you don't need a 3D scanner for this. This would be way easier with a tape measure and some very rudimentary measurements. And yes, you're totally right. That would be the easier way to do this. But I have a 3D scanner and I want to learn how to use it. And I want to kind of increase my skill set. And so sometimes you got to do things the hard way till this becomes the easy way. And did I do a great job scanning? No, the scan doesn't look all that great. It's very dirty, but I only need some basic information because what I want out of this is just a good understanding of where everything's located in 3D space so that I don't have to do that legwork. And I want to know where we can mount bell cranks and suspension pickup points on the top side of the car that can carry the load, that can be structurally sound, that are going to work on track, and so that we can just draw this up in CAD and send it off to Send Cut Send. And so as you can see, the scan itself is not pretty, but I have the data that we really need, which is truthfully only kind of these top surfaces here. I wanted to know where these diagonals are, the square structure that crosses over, so that I know where I can mount our suspension pickup points. And then I really wanted to know kind of where these vertical faces are and this cross tube. And so with this information, even though it's dirty, we should have more than enough to actually kind of set up and build this in CAD.
From there, I was able to take that scan data and import it into Fusion 360. It came in to scale, and I just had to spend a bit of time making sure it was square and plumb to our origin. But you'll have to think of the scan data as simply a reference point. We can't actually use it to build off of, and instead are going to redraw it so that we have an actual 3D model of what we see in the car. And you can see the 3D model overlaid with the scan data here. With the 3D model built, then we can actually start designing suspension components. Now, to be clear, the design of this stuff is critical. It's going to define exactly how the car operates. But there's not a lot of parts to design. We're going to need lower mounts, bell crank supports, and bell cranks themselves. The geometry of them is what's important. But I know some of you know exactly what you're looking at, and you're going to be quick to point out that if I build what we see here, I'm going to have a falling spring rate because my bell crank geometry sucks, and you would be completely correct. I threw this model together so I'd have something to show for the episode in terms of what I want to build, and now I've got to actually sit down and start doing the math. The important part here is to know that this will fit under the hood, and that I can build what I'm trying to build in the space that's available to me. I also think I'm going to have to add some support under the center of the load-bearing beam that both lower shock mounts are attached to, because under full compression of both front shocks, it could bend. But these are all details that we'll work out as we actually start building this system, and come the next episode, we should actually be making some progress towards getting this done.
So we've got a design working for this thing. It's drawn up on the computer, and again, that's just a rough draft. It's really a proof of concept. I want to start playing with it. I'm going to start playing with some of the dimensions, making sure that everything's going to work. We'll start 3D printing some parts in some of the upcoming episodes for this thing. We can start making some modifications. One of the cool things about this job is that we don't have to disable the car in order to do this. For the most part, we can kind of build the whole system that goes under the hood and then affix it into the car and then start swapping parts over. At least that's my hope. I say that now, we'll see how it goes. But I think this is the right approach. I probably should have done this from the get-go, but I was trying to retain a lot of the original suspension stuff within this car, but it's not even really in a specific class anymore. We've broken all the rules, so let's just try to get the suspension under control, and I mean that in the most literal sense. I want the dampers to be able to control the springs so that we can get the car to ride the way we want it to. That's the entire point of this, so we can get maximum compliance out of the tires and get these lap times down. I want this car to go fast, so that's what we're gonna do. So thank you guys for watching. I hope you guys enjoyed this episode. I know it was a lot of show and tell and just kind of like talking through problems, but that's a big part of this project, and that's where we're at on this project, and it's what we're gonna be doing with this thing, especially as we get out to the track and start figuring out what needs to change next. And we're gonna talk about all these types of fixes and what we wanna do with them, how to conquer these problems, what mountains we need to climb, and which ones we're just gonna go around. So let me know what you guys think. Leave some comments, subscribe if you haven't. Thank you as always for the support, and we'll catch you guys next week.